The radiant heat load is larger than the air conditioning load, and you should exclude the air conditioning compressor from the service calculations. However, because the gas furnace and radiant heat can operate simultaneously, the air handler should be included. The radiant heat totals 11,520 volt amps. The air handler is rated at 1100 volt amps. The total load for the service calculation is 12,620 volt amps. The electrical load calculation process involves several steps to ensure the electrical system can safely and reliably handle all the connected loads. First, gather all the necessary information. This includes the ratings of all appliances, lighting, heating, and cooling equipment. It's important to have accurate information typically found on the nameplates of the devices. The nameplate will list the voltage, amperage, and power factor if applicable. Secondly, calculate the general lighting load. For residences, this is usually based on the square footage of the dwelling. The National Electrical Code, or NEC, provides guidelines for determining the minimum lighting load per square foot. Multiply the square footage by the volt amps per square foot specified in the NEC to get the total general lighting load. Thirdly, determine the small appliance and laundry loads. The NEC requires at least two 20-amp small appliance circuits for the kitchen and dining areas, and at least one 20-amp laundry circuit. Each of these 20-amp circuits is considered to have a load of 1500 volt amps. Add these loads to the calculation. Fourthly, calculate the individual appliance loads. This includes large appliances such as refrigerators, dishwashers, washing machines, and dryers. Use the nameplate ratings of these appliances to determine their individual loads in volt amps. If the appliance operates on 240 volts, make sure to use that voltage in the calculation. For continuous loads, which operate for 3 hours or more, multiply the load by 125% as required by the NEC. This ensures that the wiring and overcurrent protection are adequately sized. Fifthly, consider heating and air conditioning loads. For central air conditioning, use the nameplate rating of the compressor. For heating, determine the total wattage or volt amps of all heating elements. If the heating system is electric, this will be a significant load. If it's a gas furnace with an electric blower, include the blower motor's volt amp rating. For multiple motor loads, consider the largest motor load at 125% and add the remaining motor loads at 100%. Sixthly, include any other significant loads. This could include electric vehicle chargers, swimming pool equipment, or large power tools. Make sure to use the correct voltage and amperage ratings for these loads. Seventhly, apply demand factors. The NEC allows for demand factors to be applied to certain loads, recognizing that not all loads will operate simultaneously at their maximum ratings. Demand factors reduce the overall calculated load, allowing for a smaller service size. For example, the NEC provides demand factors for ranges, dryers, and multiple appliances. Eighthly, calculate the total connected load. Add up all the individual loads taking into account any demand factors that have been applied. This will give you the total calculated load in volt amps. Ninthly, determine the service size. Divide the total calculated load in volt amps by the voltage of the service to determine the required amperage. For example, if the total calculated load is 24,000 volt amps and the service voltage is 240 volts, the required amperage is 100 amps. Select a service size that is equal to or greater than the required amperage. Common service sizes include 100 amps, 150 amps, 200 amps, and 400 amps. Tenthly, select the appropriate wiring and overcurrent protection. The wiring must be sized to handle the calculated load, and the overcurrent protection, such as circuit breakers or fuses, must be sized to protect the wiring. Refer to NEC Table 310.15 P16 for ampacity ratings of conductors. Make sure to consider the ambient temperature and the number of conductors in a raceway or cable when selecting the wire size. For overcurrent protection, select a breaker or fuse that is sized to protect the smallest conductor in the circuit. The overcurrent protection should not exceed the ampacity of the conductor. Finally, document all calculations. Keep a record of all the calculations and assumptions made during the load calculation process. This will be helpful for future reference and for any inspections that may be required. Accurate load calculations are essential for ensuring the safety and reliability of the electrical system. By following these steps and referring to the NEC, you can properly size the service and protect the electrical system from overload. Consider some additional details to help with load calculations. Firstly, understanding the NEC articles and tables is crucial. The NEC provides specific guidelines and requirements for various types of loads and installations. Familiarize yourself with the relevant articles and tables to ensure compliance. Secondly, pay attention to voltage drop. Voltage drop occurs when the voltage at the end of a circuit is lower than the voltage at the source. Excessive voltage drop can cause appliances to operate efficiently and can even damage equipment. The NEC provides recommendations for limiting voltage drop in branch circuits and feeders. Thirdly, consider future expansion. When sizing the service, consider the possibility of future additions or upgrades to the electrical system. It's often wise to oversize the service slightly to accommodate future loads. Fourthly, use a load calculation form with software. There are many load calculation forms and software programs available that can help you perform accurate and efficient load calculations. These tools can automate many of the calculations and help you avoid errors. Fifthly, consult with a qualified electrician or electrical engineer. If you are not comfortable performing load calculations yourself, consult with a qualified electrician or electrical engineer. They can help you ensure that the electrical system is properly sized and installed. Sixthly, for dwelling units, the NEC provides an optional calculation method in Article 220.82. This method simplifies the load calculation process for single-family dwellings by using a set of standardized assumptions and demand factors. It can be a useful alternative to the standard calculation method. Seventhly, when calculating the load for electric vehicle chargers, use the nameplate rating of the charger. The NEC requires that electric vehicle chargers be considered continuous loads, so multiply the load by 125%. Eighthly, for multifamily dwellings, the NEC provides demand factors for ranges, dryers, and other appliances. These demand factors recognize that not all appliances will be used simultaneously in all units. Ninthly, when calculating the load for a commercial building, consider the type of occupancy and the specific loads that will be present. For example, a restaurant will have different load requirements than an office building. Tenthly, always err on the side of caution. It's better to oversize the service slightly than to undersize it. An undersized service can lead to overloading, which can cause overheating, damage to equipment, and even fires. Always consult the latest edition of the NEC and any local amendments. The NEC is updated every 3 years, and local jurisdictions may have additional requirements. Understanding power factor is also important. Power factor is the ratio of real power, measured in kilowatts, to apparent power, measured in kilovolt amps. A low power factor can increase the current flowing through the electrical system, leading to increased losses and reduced efficiency. Power factor correction can be used to improve the power factor and reduce these losses. For motors, the nameplate will typically list the full load amps or FLA. Use this value when calculating the motor load. If the motor is used for continuous operation, multiply the FLA by 125%. When calculating the load for a transformer, use the kilovolt amp rating of the transformer. The transformer must be sized to handle the total load that it will be supplying. If the transformer is supplying continuous loads, it should be sized at 125% of the continuous load plus 100% of the non-continuous load. When calculating the load for a generator, use the kilovolt amp rating of the generator. The generator must be sized to handle the total load that it will be supplying, including any motor starting loads. When calculating the load for a UPS system, use the kilovolt amp rating of the UPS. The UPS must be sized to handle the total load that it will be supplying, including any battery charging loads. When calculating the load for a fire pump, use the lopped rotor amps or LRA of the fire pump motor. The fire pump motor is considered a critical load and must be supplied by a reliable source of power. When calculating the load for an elevator, use the full load amps of the elevator motor. The elevator motor is considered a critical load and must be supplied by a reliable source of power. When calculating the load for data center, consider the high density of equipment and the need for redundant power systems. Data centers typically have very high power requirements and require careful planning and design. When calculating the load for a hospital, consider the critical nature of the electrical system and the need for backup power. Hospitals must have a reliable source of power to ensure that life support equipment and other critical systems can continue to operate during a power outage. For calculating the load for a school, consider the need for adequate lighting and power for classrooms, laboratories, and other educational facilities. Schools also typically have large heating and cooling loads. Remember to review the single-line diagram. A single-line diagram is a simplified representation of the electrical system that shows the major components and their connections. Reviewing the single-line diagram can help you understand the overall system and identify any potential issues. The available fault current at the service entrance also needs to be determined. Available fault current is the amount of current that would flow in the event of a short circuit. The electrical equipment must be rated to withstand the available fault current. The short circuit current rating, or SCCR, is the maximum amount of fault current that a piece of equipment can safely withstand. The SCCR of the equipment must be greater than or equal to the available fault current. Coordination study might be required. A coordination study is an engineering analysis that ensures that the overcurrent protective devices in the electrical system are properly coordinated. This means that the device closest to the fault will trip first, minimizing the extent of the outage. Performing an arc flash hazard analysis is important. Arc flash is a dangerous electrical explosion that can occur when a short circuit occurs in the air. An arc flash hazard analysis determines the potential arc flash hazards in the electrical system and recommends measures to protect workers from these hazards. Using personal protective equipment, or PPE, is crucial. PPE is clothing and equipment that protects workers from electrical hazards. PPE includes items such as arc flash suits, gloves, and face shields. Following lockout-tagout procedures is important. Lockout-tagout is a safety procedure that ensures that electrical equipment is de-energized before it is worked on. This prevents accidental energization of the equipment, which could cause serious injury or death. Grounding and bonding systems ensure a safe path for fault current to return to the source. This helps to prevent electrical shock and reduces the risk of fire. Regular electrical inspections and maintenance can help to identify and correct potential problems before they cause a failure or a safety hazard. This includes inspecting wiring, connections, and overcurrent protective devices. Infrared scanning can be used to detect hotspots in electrical equipment. Hotspots are areas where the equipment is overheating, which could indicate a potential problem. Power quality monitoring can be used to identify and correct power quality problems such as voltage sags, voltage swells, and harmonics. Harmonics are distortions of the voltage and current waveforms that can cause equipment to overheat and malfunction. Transient voltage surge suppression, or TVSS, can protect sensitive electronic equipment from voltage surges caused by lightning or other events. Surge suppressors should be installed at the service entrance and at individual pieces of equipment. Emergency power systems provide backup power in the event of a power outage. Emergency power systems include generators, uninterruptible power supplies, and batteries. Load shedding is a technique that can be used to reduce the load on an electrical system during a power outage. This can help to prevent the system from overloading and can extend the runtime of the backup power system. Distributed generation is the generation of electricity at or near the point of use. Distributed generation can be used to supplement the grid power supply and can improve the reliability of the electrical system. Microgrids are localized energy grids that can operate independently of the main grid. Microgrids can provide a reliable source of power for critical loads during a power outage. Energy storage systems, such as batteries, can be used to store energy and release it when needed. Energy storage systems can improve the reliability and efficiency of the electrical system. Demand response programs are programs that encourage customers to reduce their electricity consumption during peak demand periods. Demand response programs can help to reduce the load on the electrical grid and can lower electricity costs. Energy efficiency measures can reduce the overall electricity consumption of a building or facility. Energy efficiency measures include installing energy-efficient lighting appliances and HVAC equipment. Building automation systems can be used to control and monitor the electrical system and other building systems. Building automation systems can improve the efficiency and reliability of the electrical system. Considering renewable energy sources such as solar and wind power can help reduce the reliance on fossil fuels and can lower electricity costs. Renewable energy sources can be integrated into the electrical system to provide a clean and sustainable source of power. When calculating the load for a marina or boatyard, consider the unique electrical hazards associated with these environments. These hazards include the presence of water, the potential for corrosion, and the risk of electric shock drowning. Ground fault protection is required for circuits that supply power to boats. This helps to protect people from electric shock drowning. When calculating the load for an agricultural building, consider the specific electrical needs of the agricultural operation. These needs may include power for irrigation pumps, lighting for livestock, and ventilation for greenhouses. Article 547 of the NEC provides specific requirements for agricultural buildings. When calculating the load for a healthcare facility, consider the critical nature of the electrical system and the need for backup power. Healthcare facilities must have a reliable source of power to ensure that life support equipment and other critical systems can continue to operate during a power outage. Article 517 of the NEC provides specific requirements for healthcare facilities. When calculating the load for a data processing center, consider the high density of equipment and the need for redundant power systems. Data processing centers typically have very high power requirements and require careful planning and design. Article 645 of the NEC provides specific requirements for data processing centers. When calculating the load for a wastewater treatment plant, consider the specific electrical needs of the wastewater treatment process. These needs may include power for pumps, motors, and other equipment. Article 670 of the NEC provides specific requirements for wastewater treatment plants. Understanding that electrical plans are a set of drawings and specifications that describe the electrical system for a building or facility. The electrical plan should include a single-line diagram, a panel schedule, and a lighting plan. The panel schedule is a list of all the circuit breakers in the electrical panel and the loads that they serve. The lighting plan shows the location of all the lighting fixtures in the building. Specifications are written documents that describe the materials and workmanship required for the electrical installation. The specification should include information on the type of wire, conduit, and other materials to be used. Electrical permits are required for most electrical installations. The permit ensures that the electrical work is performed in accordance with the NEC and other applicable codes. The electrical inspections are performed by local building officials to ensure that the electrical work is performed in accordance with the NEC and other applicable codes. Electrical safety is paramount. Always work safely when working with electricity. Wear appropriate personal protective equipment and follow lockout-tagout procedures. If you are not qualified to perform electrical work, hire a qualified electrician. Regular electrical maintenance can help to prevent electrical hazards. Inspect wiring, connections, and overcurrent protective devices regularly. Understanding energy management is key. Energy management is the process of monitoring and controlling energy consumption. Energy management can help to reduce energy costs and improve the efficiency of the electrical system. Load balancing is the process of distributing the electrical load evenly across the phases of the electrical system. Load balancing can help to prevent voltage imbalances and can improve the efficiency of the electrical system. Power monitoring is the process of measuring and recording electrical parameters such as voltage, current, and power. Power monitoring can help to identify energy waste and can improve the efficiency of the electrical system.